So double integrals, we get to integrate twice, yay! The trick here is to remember to keep one variable constant, or when we're going to get to triple integrals later. So whatever variable you're not integrating with respect to is going to be treated like a constant. That's the big thing, and that's the easiest place to screw this up. Be very careful. We talked about Fubini last time. What did Fubini give us?
The same thing that Clairaut gave us except for integrals.
Okay, so what is Fubini's theorem say?
The order doesn't matter.
Order of what doesn't matter?
The order of, like the dx to y.
Order of integration doesn't matter? Okay, I can integrate dy dx or dx dy. Okay. Keeping in mind, I may have to adjust my bounds. In the previous section, we just had rectangles, right? Our domain was a rectangle, so it was very easy just to switch them. Here we see that we have regions that are more fun, more interesting. So I definitely can switch my bounds, switch my integral order of integration. I'm just going to have to make sure that I do it in such a way I do not change my domain, that I still keep in mind what I'm working with. Okay. So we've done a few maybe, huh? One, two. Okay, we just set this one up. Okay, and so let's just leave it set up. I'm confident that you can integrate that. Do you want me to tell you the answer? The answer is 3/10 if you want to try it on your own.
That's what I thought.
Okay, so let's do this one. Really or not? You messing with me? Huh?
I was totally messing.
So you just looked at that and knew?
It looks like 3/10 of it.
Looks like one of those kind of.
Read this to me.
Find the volume of the solid that lies within the surface C equals 2x equals y squared above the region bounded by x equals y squared and x equals y cubed.
Okay, so we need to draw a picture, but we don't have to worry about the 3D picture. What picture do we need to draw? Domain. So what curves?
Y equals x, or x equals y squared and x equals y cubed.
Okay, these are x curves, right? So I'm drawing my xy plane. I'm not going to draw in 3D. I'm just drawing the domain, and I'm going to project up for the z. Okay, so x equal y squared is the sideways parabola like this. And then, ooh, x equal y cubed. What is that?
That S thing.
It's like an yeah.
Okay, I'm just going to draw it over here for now, and I'll erase it in just a second. But I know, y'all are just telling me it goes like this. So I don't, what's going on here? Do they cross? Do they, I mean, is it above? Is it below? What's going on here? It's not clear to me. Is it clear to you?
They'll intersect at 1, 1, won't they?
Let's see. Will they? Okay, so x equals y squared, and I need to change the size of this. Hold on. X equal y squared, and x equal y cubed. So I just said x equal to x. And we never, ever, ever divide by variables. We always move everything over and factor the F word in math. Check me, make sure I don't do anything stupid. I'm kind of brain dead. Is that good?
Y equals 0 and 1.
Okay, so there's going to be 2 intersection places, so I'm just going to erase this. Okay, and if I look at x equal y squared, and I plug in 0, x is also 0, so I get 0, 0 is the intersection point. And 1, 1. How do I know which one's on top?
From 0 to 1, the cube would be smaller than the fraction. So wouldn't the y squared be on top?
Okay. Okay, let me just do this real quick. So I'm graphing this. That's beautiful. Pretend that's what it's supposed to be. And I'm graphing this, and I'm not sure what's going on here. I don't know what's going on here. So I'm just going to graph it here. So between 0 and 1, which one's bigger, you were saying, Anita?
The
Y squared or y cubed?
Y squared.
Yeah.
Is that true?
Y squared
Because it's a fraction, right? Okay. And for x bigger than 1, which one's bigger?
Y cubed.
So they flip-flop. So y squared is the biggest right here, and y cubed kind of goes kind of, this is hard for me to draw. I should have used different colors, right?
Yeah.
Okay. Let me just, okay. Okay, so this is y squared, like this. I'll just do this one, this purple color. So y squared is bigger than y cubed. This is really weird. So, kind of like this then.
Yeah.
It's really hard to, so I'm really going to exaggerate it right here, okay? It's not much bigger, but. Okay, something like that. And this one is y equal x squared. This one is y equal x cubed. Now this is y equal x cubed, and this one's y equal x squared. Just got to keep it straight. Is that okay? So what do I do? I'm really only interested in this little chunk, right? That little piece right here. So I'm just gonna, that's really bad. Yeah, I just want to make it really big here. I'm really going to exaggerate it, okay? Make it really big. But here's my picture. What's the matter, Josh? You don't like my picture?
No, I said it's a banana.
No, I'm writing this wrong. This is x equal y squared. Nobody said anything, and I wrote this wrong.
Oh, yeah.
I wrote all of it wrong. Thanks, guys. Okay, so what's with this one? This is x equal y squared and x equal y cubed. And then this is x equal y squared, x equal y cubed. Okay, so this top one is x equal y squared, x equal y cubed. Okay, that's the hardest part, is trying to figure out what you'll get. Okay. So now we're going to find the volume. For volume, I do a double integral of my z. Okay. It gave me z, 2x plus y squared. Do you want to do dy dx or dx dy?
You
No, you pick.
yeah, Josh.
Let's do dx dy.
Dx dy, so you want them to go sideways?
I guess it doesn't matter, does it?
This one doesn't matter.
Yeah, that's fine. Takes too long.
Sideways? Okay, so that's dx dy. So it's top minus bottom. Well, the top is actually the top down. I'm sorry, right minus left. What am I doing? I'm sorry, guys. This is my 4th class today, and I'm a little brain dead. Okay, right minus left. So right and left.
So x, y squared on the bottom, cubed on the bottom,
Y cubed on the bottom and
No,
y.
Other way.
squared on the top, right?
Other way.
This one.
It's right minus left.
Yep,
Yeah.
it's right. I did top minus bottom. Right minus left. Okay. Because the right one is y cubed this time.
Oh, okay.
And y squared, we'll just set it the other way too. Y squared.
Yep.
And where do these rectangles exist?
0
0 to 1.
0 to 1. Okay. My little marker. Let's set it up the other way. Or, so if I do it this way, it's going to be dy dx. And so my region, I'm going to scroll back and forth, I guess. If this is x equal y squared, and I want to do this one up and down, this is
Top minus bottom.
square root of x equal y, and
Cube root of x.
cube root of x equal y, and then I do top minus bottom. So the top was root x, is that what you said?
Yeah.
Is that right?
Yeah. And then cube root on the bottom.
Cube root of x.
That takes us from 0
And
to
then
1.
0 to 1. Just so happened because it was 0, 0, and 1, 1. Not always that way. Okay, and the answer is 19 over 210, if you want to calculate it.
I was guessing somewhere around there.
Okay, so here's the little summary. The book always talks about, is it region 1, is it region 2, look at it. I think it's easier to draw the picture and visualize. Is it easier for me to think about up and down or right and left? And then go from there. So if you do it z, if you do dy dx, your rectangles go up and down. So this is going to be the top function, and this is going to be the bottom function, right? If you go dx dy, your rectangles go sideways. So this is right, and this is left. Remember, when you're integrating this, you're doing top minus bottom, the upper bound minus lower bound, so you're doing right minus left. You're doing upper minus lower, so you're doing top minus bottom. It's always biggest minus smallest when you're doing your rectangles, right? Is that okay? Gonna set up another one? At this point, I'm confident you can integrate this. Is that a good assessment? Yes?
I hope so.
Yes? Okay.
Let's hope.
I think the setup is the thing we maybe need to practice on. Let's hope. Yes, let's hope. If you can't, then I'm in more trouble than I thought. Okay. Okay.
Yeah, I'm not really-
Read this to me. You're not what?
Find the volume of the tetrahedron bounded by the planes x equals 2y, z equals 2, and x equals 2y, and x equals 0, and z equals 0.
What in the world are we doing?
We're going to find the volume of the tetrahedron bounded by the planes.
Okay, when I'm doing a volume, all I know at this point is volume is the double integral of z dA, dx, dy, dy, dx. So I need to find what z is first.
Yeah.
2 minus x minus 2y.
Z is what?
2 minus x.
2 minus x
Minus 2y.
minus 2y. I want to know it lies under this, right?
But it also says z equals 0, so that just like,
Well, z equals 0 is the xy plane. That's going to be part of my domain, right? It's going to be, what is this right here? It's a plane, right?
Yeah.
So I have, okay, this is going to be
So
beautiful.
you just have like 4 planes.
Uh-huh. Okay, y'all be nice to me, okay? No, you're not always nice to me. Okay, so
So would you get a
X.
formula based on the sides or something?
yeah, hang on. We're going to draw the domain based on the sides, based on the what's happening in the xy plane. Okay, so my picture looks like this. Please be nice to me. When z is 0, I have x plus 2y equals 2, right? I get 2 equals x plus 2y, which I know how to graph that, don't I? X and y. I can do my intercepts. When x is 0, y is 1. And I probably should do this bigger. And when y is 0, x is 2. 1, 2. So I have this line in 2D. In 3D, it's a,
Plane
Plane?
standing up.
okay. I also know that x equal 2y. X equals 2y. That's the same as y equal 1/2 x. So I can draw something like that. I should probably make this a whole lot bigger, but I will in a second. So I have these pictures. Okay. And this is in my floor, and the z-axis is like coming out of the paper. So if I'm looking at this, I have something like this. Yes, really?
Wouldn't it? I don't see that.
Okay.
The planes would stand, well, I know, why is it slanted like that?
That's what it's, yeah.
Okay, let's start over. Okay, let's just look at when z is 0. Let me do this again. Let me do it bigger.
But since they intersect, which piece are you taking?
Well, I'm intersecting this and this. When z equals 0, that is the xy plane, right? I'm looking at the floor. When z is 0, I get x plus 2y equals 2. Do y'all agree that this is a line? Okay, I'm gonna just, a reason I'm redoing is I want to draw it bigger. Hold on, I'm just gonna do it back here.
What if we could graph this on our phone, Josh?
Yeah, I know.
Okay, so this means we said y is 1 and x was 2. Okay, and this is going to be a line.
So the plane's not standing straight up.
No, it's not a vertical plane, no. So this is x plus 2y equals 2. That is the intersection of this plane. That's where that plane cuts through the floor.
Right.
Okay? This is the y plane, I mean the y-axis, the x-axis is the xy plane. This is the floor.
So it's coming out at us.
And then the other one is x equal 2y.
Okay, so at origin it's at 2z. That's why you graphed it to where it was slanted up to 2 on the z-axis.
Yes, I'm going to do that one in 3D in just a second. Hang on, let me do what I did earlier first. X equal 2y means y equals 1/2 x. So I have 0, 0. When x is 1, y is 1/2, right? Grows very slowly. So it looks like that.
Yeah.
X equal 2y. So I'm looking at an x equals 0. Well, we know that's just this line, right? So I'm looking at this region right here. Can y'all visualize that? Just in the xy plane in the floor. Because I'm looking at when z is 0, then this becomes a line, I have a line, and I have a line. Okay, if I'm looking in 3D, let's do in 3D over here. Okay. If I'm looking for z, let x be 0 and y be 0. I get 0 plus 0 plus z equal 2. I get the point 0, 0, 2. Trying to figure out where it crosses that axis.
Which is why they slant.
Yep. And then
Okay.
I'm going to draw this in the floor again. So kind of like, I should do it blue. Okay, I'm going to screw this up. It's along the y-axis, so this, and it comes out like this. There we go. So the plane x plus 2y plus z equals 2 is this front surface. X equal 2y is this.
So do that side.
This is x equal 2y. Coming out at us, right? If we're looking at the floor, we're looking down on the z-axis. Right?
It's just this side facing this one.
So you have one like this and one like this. That's that one and that one.
But where does x equal 0 come in?
X equals 0
Which means
is
Bounds it by that.
this right here. It's x equals 0 is
It's
y.
like
I can't reach it. The y-axis.
Because without it, it would just.
It makes it. It stops it from going on forever this way. That's what we. That's this third line is how we get the triangle right here. X equals 0 right here. Sorry.
so x equals 2y is straight up.
X equal 2y, if you're looking at the floor from the z-axis, looks like this.
But the other one's slanted.
And where's z equals 0? I'm getting my.
Because
Z equals 0 is the floor.
Z equals 2.
Z equals 0 is this.
To make that point.
This is hard to visualize. This is the hardest part of calculus.
X equals 2y isn't slanted, it is straight up and down, right?
In the floor, though. Okay, let's hear it.
Well, that's what I'm saying. Like,
Yes,
like
here's the
other
floor.
ones.
Here's the floor. This is the xy plane in quadrant 1, right? Quadrant, opposite point. Okay, so Chris, get out. This is the x-axis, and that's the y-axis. So I want you to count, let's go by 3. Let's say 3 is 1. So you count out, you're the y-axis. You need to go out 3, and I'll go out 6.
Y is 1x2, right?
43.
1, 2, 3, 4, 5, 6. Okay, so there's a line right here between us. Come stand up here. Come on. Jennifer, come here.
Anyway.
We're gonna make a plane. Connect the dots between this. Come stand right between this. You see the plane?
It's very colorful. It is, yes.
Okay, that is x, no, that is x plus 2y equals 2. That's us.
Right.
Okay? And then there's another one.
The X and Y, but one had X.
And I want you to stand right behind Jennifer.
You also get one.
You can't see her name, but. So from her, the corner through them is this other plane. So do you see this triangle right there between Chris, Melissa, and Jennifer?
Vaguely, yes.
Yes. And then there's a plane coming down from the ceiling
Okay, I
down to Jennifer's feet.
Yeah, I do picture myself, so I got it.
Active learning.
On my phone.
Okay, so the hardest thing is you got to figure out what's going on. You got to visualize it. Okay, so let's look at this picture. And I don't know why that line is there. When y'all do that?
Yeah, I ran up there while
You ran up there and did it?
How many steps?
You must not have because it's didn't erase it. Okay.
The line was from when you were counting 1, 2 for students.
Oh, thank you. It was a tick mark, right? Okay, pretend those are straight because they're not. I'm having a hard time. That'll be nice to me. Okay. Now here's the interesting part that when I was a student, until I drew this, didn't make much sense to me. I'm always thinking about the floor is my domain. So here's my domain. Here it is right here. Let me color it in red. Well, I don't want to color it red, so I don't want to mess up that. But right here, this is the floor. And I'm always thinking about projecting up to Z. Okay? So when I'm standing right here, I'm projecting up to that surface. If I'm standing right here, I'm projecting up that high. If I'm up here, I'm projecting up that high. Do y'all see that? That the height of Z changes because of this slanted plane, which I labeled and I erased. What was it called? It was x plus 2y plus z equal 2. Y'all see that? No matter where I stand, my height is given from the domain upward, up touching that surface of the plane. Is that a little better? Can you kind of visualize that?
No.
Okay. Okay. So there's my picture. I want to come up with this. So I know what z is. I'm going to scroll back and forth, I guess. Okay, where's my thing? Okay. So I'm going to do a double integral of z, which is this guy. 2 minus x minus 2y. Okay. Because that means I'm going to start out at the floor and I'm going up some height z, and z is determined by that equation of that plane. Do you see the red arrows? Yes? Okay. Now, do I want to do dx dy or dy dx? Here, do I want to go up and down or sideways? Let's go up and down. I heard that first, and we'll talk about why we do not want to go sideways. Up and down. Can y'all see the up and down? Is that a better color? I'll use black. Okay. So if I go up and down, that's dy dx or dx dy? Dy dx. So I do upper is the upper bound and lower bound. And I label, here they are. So the upper is x plus 2y equals 2. So that means y is 2 minus x over 2 over 2. Y is 1 minus 1/2 x. I hadn't done it yet.
Oh.
Okay. And this one is y equals. Okay. And where do these black rectangles exist? From 0. We never found what this was. What is it?
The X value?
Did we find the x value? It looks like it's 1. Is it 1? Do we ever just look at the picture and just go with it?
No. Well, 2y equals.
2y equals that.
So 2y equals 2 minus x, and 2y equals x, right? So 2 minus x equals x. 2 is 2x, x is 1, you're right. So this is the point 1 comma 1 half. Thank you. So I go, wait, what?
When did you do, wait, just two
I just saw both of them had a 2y in it, so I saw both for 2y so I could set them equal to each other. 2y equals 2 minus x, that's this guy.
Oh.
Okay,
Oh.
okay.
And then 2y was x.
I got you.
So what did I say, 0 to 1? Okay. Do you want to integrate this one? Yeah? Don't let me forget to do the other way, okay?
Isn't the 0 to 1 on the y part?
The 0 to 1 half on 1. Isn't it? Even if you look at the slope of this, it's rise over run, up 1 over 2.
Yes, never mind, okay, never mind.
So this will be 2y minus xy minus y squared. Please check me.
What? Or integrate.
I mean, I'm just making stuff up just to see what you're going to
Yes.
say.
That is correct.
Wait, correct?
Okay. This is going to be fun, right? Oh man, I'm running out of room. Crap.
You erased that?
I'll put it over here. This is so Quentin will cry. Hang on. He says, we can't do that. Not today?
Not bad.
He's not even writing anything down.
Smiling.
Oh, shoot. That's what I get for being obnoxious.
Why did you choose to integrate this one?
Because Chris wanted to.
What?
Yes, you did.
I did not. That wasn't me. Look at that real quick.
Yuck. Oh, some x's will cancel, huh?
What's that one?
This one's going to cancel with this one. Yes. And that's
You're
it.
still left with -2.
That was kind of disappointing.
One half.
Okay, so can I cancel the x squareds? No. Yes, yes.
Yeah.
This one and this one can cancel with that one. Right?
Yeah.
And that's about all. 2 minus 1 is 1. So 1 minus 2x plus 1 half x squared. That's a little better. Check me because I do silly things.
Yes, which one's it?
Did you forget the 2?
Where's the 2?
See the first X you crossed out?
Two minus one.
I don't
Oh,
know.
Gotcha. Gotcha.
No, you
Never mind. Never mind.
Yeah.
Good.
Am I good?
Yeah.
Okay. I do want to point out one other thing. What if we'd done it Justin's way?
But you had two equations.
So let me, can I scroll over? Y'all can all do this, right? Okay. If we had done it the other way, we had done it sideways, we'd have had, oop, that's not what I want. We would have had a rectangle here and a rectangle here. We'd have had to do, let me sit down here. 0 to 1 half 0 to 2y, 2 minus x minus 2y, dx dy plus
1/2.
to 1, 0 to 2 minus 2y.
Yeah, I don't like doing that.
You could do it, but you have to do right and left. Zero's the left every time, but it's 2y in one place and it's 2 minus 2y in the other place. So it's a lot more complicated. Okay, shall we try another?
Yeah, but it's gonna get harder.
This one says setup only. Read it to me.
Evaluate the double interval of x, y, dA, where d is for each bounded by y equals x minus 1 and y squared equals 2x equals 6.
Okay, so the first thing I need to do is draw it. Okay, I know what this one is. This is a line. Do you know this one off the top of your head?
It's a route.
Sideways parabola. Can you be more specific? So we know if we rewrite this, let me do it right here. This is y squared minus 6 equals 2x. So x is 1/2 y squared minus 3. At this point, I don't really need to know very specific stuff. I just need to know where the vertex is. Basic idea. The vertex is at what comma 0? Negative 3.
Yes.
Negative 3, 0. So I'm just going to draw a rough sketch. I have something like this. I can figure out what these intersection points are. Right now I don't care. And x minus 1, I'm just guessing. It may intersect here. I don't know. But I know x minus 1 kind of goes like this. I don't know for sure where this intersection is. I can find it. I did what?
I got it.
I'll explain.
Okay. So my picture looks like this. Like I said, this could be over a little bit. It could go right there. Let's figure out where the intersection points are. Well, I have a y squared, so I can square this and make this a y squared, right?
Yeah.
But I did something
Wait,
wrong.
yeah.
You can't cancel your two.
Oh, I can't cancel them. They're different sides. What am I doing? I'm sorry, guys. I'm incredibly brain dead. I was like, that's too easy. X squared minus 4x minus 5, right? 1 and 5, and you said negative 5, positive 1? So negative 1, okay, then I was right, we're off this way. So this is negative 1, the y value is, actually, no, I wasn't, was I? Oh, I'm thinking y equal negative 1. If x is negative 1, y is negative 2. Okay, so I was good, I'm good here. Negative 1, negative 2. And x is 5, it's over here somewhere, 5 and 4. Okay, so I want this region in here. What is yellow color? How's that? You like the yellow? That's pretty.
I think you should use yellow.
Okay.
Not for writing.
Yeah.
Okay, so there's the intersection, so I need to decide up and down or sideways?
I'm thinking sideways.
Sideways?
Up and down.
We'll do up and down in a minute. So sideways, I'm going to have, let me just set it up here, the integral of x, y, sideways is dy dx or dx dy?
Dx dy.
Dx dy, and I'm going to do right. This is in terms of x, so I need x equals stuff. It was y equals x minus 1, so now x is going to be y plus 1, and that's the right. And then the left is the curve, which is a good thing because I don't want to take a root, right? So I can just use this. 1/2 y squared minus 3, check me. Is that okay? Okay, and then where do these rectangles exist? From y?
-2 to 5.
-2 to
A 4.
4. Da, 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 da. Wasn't that easy? Or you could cry your eyes out and do it the hard way. You'd have to subtract the function minus itself, and over here you'd have to do the function minus a line. So you need 2 integrals.
That would be pretty. Why is it that big?
This is the best way to do it. Okay? How do we feel?
Hungry.
Hungry, me too.
You just
Wait,
have lunch.
good? All right, 4 classes in a row. I've not had anything to eat.
Let's, how about we all take a break, go get something to eat?
Okay,
Just
turn the
right.
page. No, I'm good.
Oh.
Look
Let's say I
at
was like,
this. Isn't that exciting?
No, square root of pi.
Square root of pi, yes. What do we do? Just when you thought it was safe to go back in the water.
Land sharks. No, I quit going in the water, but then you made land sharks, and they came on land, and they got me.
Okay, can you integrate this with respect to x?
My favorite. Oh, yeah.
Try it. U is x squared. So du is 2x dx. I don't have any x here. So can you integrate this with respect to x?
No.
No.
So flip it. Do dy dx, but split your bounds, like your integrals.
So just switch my bounds like this? Why not?
Because you can't, you end up with a.
Sure I can. I just did it.
You're right. What was I thinking?
Why is it wrong?
Because you end up with a y.
Because of how you're writing it.
You won't find a number.
How do you subtract that?
When I end up with this, first off, you're right too. But just the obvious thing is, I'm not going to get a number. Remember we learned a long time ago, if you have an integral with bounds, your answer should be a number. I'm going to get a function. I'm going to get y stuff. So you can't just switch them, okay? So don't do that, please. That makes me cry. Okay, how do we handle this? Well, we go back up here and we say x equal y and x equal root pi were my original x bounds, right? And y equals 0, y equal root pi were my original y bounds. I need to graph those. Right? Right?
Yeah, right. Yeah. Of course.
Why?
I would say that one wrong.
Johnny Raincloud over there. Okay, x equal root pi. What is that? Vertical line, right? And x equal y. Oh, that's easy. I can do x equal y. Right?
Oh, I can do that too.
I think x is 1 plus 2.
Okay.
No longer.
And then x equal root y. I mean x equal root x. Root pi. I cannot talk today. Oh my gosh. You ever wake up stupid? That's how I woke up
Every
today.
day.
Okay, and I'm just eyeballing it. Who cares what it is? It doesn't have to be perfect. I know it's the square root of 3.14. It's just going like this on my picture, okay? And then over here, I'm going to do that one. Pretend that's straight. Okay.
That's straight. That's pretty straight. That's straight.
Pretend it's parallel.
That's
Okay.
pretty good.
X equal root pi and y equal root pi. Okay. Now, looking at my original integral, I had x equal y and x equal root pi. Since it's dx, my rectangle goes sideways or up and down?
Sideways.
The original rectangle was sideways. So I'm going to draw a rectangle here that's sideways. Do I put it here? That's not the color I wanted. Do I put it here or here?
On the
I have
right.
no clue.
I don't know either.
No.
Well, because y
wait.
equals 0. Right?
Okay,
Yeah.
but I want right and left. My upper needs to be the right.
Your upper is x equals y.
My upper is x equal
Oh.
root pi.
Dang.
X equal root pi right here. And the left is x equal y. Like this?
Yeah.
And let's check it. If I do that, then are the y bounds okay? From 0 to root pi. Is that okay?
Yeah.
Okay, so does everybody agree? I'm going to use the yellow because y'all like the yellow. This is my region. Hey, I'll draw it again. Fix it.
So now we just redo it all
Oh,
because
Yes.
we have the picture.
now we redo it all because we have the picture.
So the fact that you gave us an equation, the original one is irrelevant because you just make our own.
What?
He's being sassy.
Okay, so now I need to change this to a rectangle going up and down.
So we're going to go dy dx on this, right?
Yes, I just copied it the same way it was, didn't I? Now it's going to be dy dx. So I'm going to go up and down. So I'm going to do upper as my upper bound. And, okay, so with respect to y, so this is going to be y equals x, and y equals 0. And then the x's of this blue guy are going to range, I'll just make it real pretty, are going to go from what to what?
0 to root pi.
Does that make sense?
Yeah.
And so now this rectangle goes up and down. Okay, let's integrate it. Because we didn't know how to integrate the other one, right? This is trig, your favorite. With respect to y, this is a constant. Yay.
So it's just cosine x squared y.
Thank goodness for small favors, right? Don't worry, we'll do a hard one later.
Oh, yeah.
I know you were
You
worried.
know just what to say.
Okay, and then when I plug in y, I get minus 0.
Yeah.
So do I have to plug it in?
Oh, now
Okay.
we can use u subs.
Now I can use u subs. How nice.
Justin had this figured out before we even did it.
Okay, if I do u subs, I'm going to get cosine. I'm really integrating. I like to do the u subs now. You're in Cal 3. I like to do it over here with Scratch and not mess with my original problem. Now I have cosine u and I have a 1/2 du.
Yeah.
Right?
Yeah.
Whose derivative is cosine? Sine. Instead of u, I put x squared. I have my 1/2 right here, right? Go a little fast. Slow down.
No, that's
Take
what
it
drives me
easy.
crazy. I have to slow down.
Okay?
Thank
We got this?
Yeah.
Everybody see I just did it over here and that's just my scratch? Chris? Chris doesn't look happy.
I did that last night. So I'm
You did this
okay.
problem last night?
No, well, you know, number 2 on that homework. You have to do all that.
Well, say I'm like,
15-2. I'm happy.
Just came out.
I like this a lot better than.
What is this, Quentin? Somebody answer me. What is this?
zero.
Wait,
It's 0.
zero.
It's like a stop sign.
How did that even happen?
All that work for nothing.
Wait, how was it 0?
That's gonna be on the test.
How was the area of that 0?
Why? Then why this was easy?
Hold on. Explain to me how the area.
Wait, does it bother you the answer 0?
Please go
Can
back
you
up to the
scroll back
picture.
up to the picture, please?
Because it goes into the negative. Wait.
How was the area of
Y
that
is at
0?
0.
This may not represent an area. This is a volume, first off. It would be a volume.
Oh.
But, what does cosine look like? Okay, question. Is this region,
Oh, I get
if
it.
you look at this, if you look at cosine, half of it's above and half of it's below the y-axis. If you graph it above the z, is it half of it above, half of it below?
I guess.
So wouldn't it make sense that it's gonna cancel out?
I'm just gonna write there, you know?
No.
Zero.
Okay.
Or a stop sign.
Properties of double integrals. Excuse me. What do you think this is?
Zero.
No.
Double integral of f of x, y plus double integral of g of x, y. Well, did we do that already?
I think we did. I don't know why we're doing it again.
I feel like you should have done that before, we just said all that.
Oh, same page.
I was gonna guess on this one, but I guess you just gonna tell me.
You're cribbing my style. Come on. What about this one? Take a guess then, Josh.
Wait, what?
Double integral will be greater than double integral.
Oh, yeah. That's like fourth grade.
Yeah, we stepped up a little bit, but not third grade anymore, right? Fourth grade.
Yeah, fourth grade, obviously.
Okay, so if D is a union of two regions D1 and D2, where they don't overlap except perhaps on their boundaries, so I have something like this. Maybe that's D. And this is D1, this is D2. Overall, that's D.
Yeah. All right.
You don't like my picture?
I don't understand.
Okay, yeah.
Then the integral of this is going to be the integral over region D1.
Plus.
Plus the integral over region D2. Okay, maybe that's like the end of fourth grade.
Okay, what do you think this is?
It's a sum of integral of 1.
Double integral of 1
1/2
over
squared.
D.
1/2 D squared. AD, of course.
You do a double integral of 1, or you're doing 2 dimensions, you're getting an area. If it's a double integral over region D, you're getting the area of that region.
Yeah.
You're killing me. Okay. And then this is your our favorite one.
If I have a square and I double integrate it, I get the area of the square.
Okay, so this is capital M, and this is little m, and my function is somewhere in between. Same one. MAD, that's M times the area of AD is less than or equal to
Big M.
the area under this guy, F, is less than or equal to capital M times AD. We did this in Cal 1 with single integral. M times AD is the area of the domain, right? Remember, we're talking about volume now, so we need an area times another dimension. Here's the third dimension, and we're multiplying by the area under Z. Can you visualize from Cal 1
Yeah.
that the area of this top box is bigger than the area of this little box?
Yeah.
And the area under this purple one is in between? So now we're extending it. Instead of making it a single integral, we're making it a double integral. We need area now because three-dimensional is volume.
Yeah.
That's all we're doing.
Okay.
Okay?
Yeah.
Is that the last thing on this? That's it.